Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello, welcome to the Pytorch tutorial series. In the previous video, we saw how to convert any surnames or any letter, for a matter of fact, into tensors. And today we shall train our model to learn character by character so that our model can learn how to construct a surname and tag them according to their classifying nationality. And to do that, we are defining one function. This is called category from output. In this, we are inserting our output that comes from the previous layer, that is line to tensor or letter to tensor, that converts every letter and surnames into tensors. And Pytorch works with tensors. So when we insert our output or tensorized surnames into this function, it takes the top probability for the category that it belongs to according to the model, and it prints it out. And it's very straightforward. As you can see, it has a score. It gives it a score of minus 0.659, and it belongs to the category Korean, and it also prints the index of that category, that is 9. You might remember from the previous video that there were 18 categories. So in this case, it's actually confused about the category. So yeah, this time it predicted correctly. It predicted English. So after, you have to remember that it's after only one RNN module, but once your model runs for many iterations, your model will learn eventually. So anyway, let's not spend more time and build our model. So in this case, we are actually building a stochastic gradient descent type model, where our model will pick up any random surname and update our weights and biases according to those changes while back propagation. And to implement that, we are creating one random training example that picks up any random surname from the dataset and train our model on that. And it's very straightforward. So you can see it took nationality English and a surname Birch, and it took nationality Japanese and took a surname Ichigawa, and it's like that. Anyway, let's move on. Okay, we are taking our loss function as NLL loss. It's a very good loss function when we are implementing log softmax. You might remember from the previous video that we are using log softmax in the last layer of our RNN module, and it's also a very good function for classification task. The learning rate has been set to 0.005. Don't make it too small or the model will not run, and also don't make it very big. That will explode our learning rate, and in RNN that's a big problem. The exploding and vanishing gradients, as I have mentioned earlier. That's why we use LSTM, but in this case we will train simple RNN module. And the first function is train. In the train, first we initialize all the hidden layers, then we call 0_grad that initializes all the gradients after back propagation, and after that we generate the output from that RNN module, that is one RNN module, and the output from that RNN module, that is input to the next RNN. And like that we create a for loop that actually helps us inserting the output from that hidden layer or RNN module to the next RNN module, and we train it until we met all the inputs. So after that we calculate loss. We do loss dot backward, that is basically backpropagation. And you might notice here that we haven't explicitly mentioned any optimizer function. That is because we are doing everything manually here, just to give you a flavor of how to do it manually. So here, while I could have done optimizer.step, instead of doing that, I am updating my variables, as in weights and biases, manually in this layer. So this actually stands for W equals to W minus learning rate multiplied by gradient of W, and B equals to B minus learning rate multiplied by derivative of biases in the backpropagation stage. We run this one also, and here we are implementing 100,000 iterations. I'll suggest you make it bigger than this if you want. It will take more time, but your model will learn better, because remember, in this case we are taking randomly from our dataset and training on that. It's a stochastic gradient descent model, and we are printing after every 10,000 iterations. So let's run our module. Okay, now our model has trained on the input dataset. So it has taken random surnames from the dataset, and it did it for 100,000 iterations. You might notice one thing, that our loss function has been fluctuating a lot, from 0.2343 to 1.7772, and like that. In this case, you have to remember that we are creating a structure of this training dataset or the training model that resembles stochastic gradient descent, where it takes one example and updates our model. And if you have watched a previous video about the stochastic gradient descent, normal gradient descent, and batch gradient descent, you know that in stochastic gradient descent it fluctuates a lot. So although we haven't explicitly mentioned any optimizer function in our model, it's basically a batch gradient descent model, or we can call it stochastic gradient descent model. So the optimizer in this case is stochastic gradient descent, hence a huge fluctuation in the loss function. But don't worry about it. This is a bit of a technicality. In the training module, you can see that we are printing out how many, after every 10,000 steps, how many it guessed correctly, how many was wrongly categorized. So this one is correctly categorized, this one is wrongly categorized. It should have been English, but our model categorized it as Scottish. So of course this will happen. It will categorize some surnames correctly and some surnames wrongly, but let's see how to evaluate and predict. So in the evaluation step also, we initialize all the hidden layers, and we generate the outputs and the hidden outputs from each RNN modules, and we return the output. And in the predict function, we give it a input surname, and we generate 3 predictions, as in the top 3 predictions in that stage. And we call torch.noGrad, because we don't want any gradients at that level. And we call the evaluate function that we created previously. So in evaluate function, we pass as argument the line to tensor. So it will convert the input surname into a tensor, then it will evaluate, as in pass it through all the layers, and it will generate the prediction, and we are printing out the top 3 predictions So that's the whole gist of this predict function. And in predict, you can predict any surname you want. Like this is Rodriguez. Remember, this I is a bit different. It's not exactly I, but we are using Unicode to ASCII that converts everything into English or ASCII. In this case, it predicted perfectly. Rodriguez is a Spanish surname. Then Weber is a German. Let's see. Yeah, perfectly identified. Mikolov is a famous name in AI. Thomas Mikolov is a researcher in Facebook. You can check his works. It's amazing. And it's a Russian name. Let's see. Perfect. So here, guys, you have the model that learned letter by letter, or I can say character by character, the surname and which nationality it belongs to. If you want, you can add your own nationality or surnames of your nationality into the main dataset and upload it and train your model on that. And after that, it will be able to identify your surnames perfectly. Thanks for watching.